Here's a video for notes 3-3, characteristics of exponential functions. So in the previous lesson, we learned how to graph exponential functions, and now we're going to look at a graph and be able to identify these 5 characteristics of exponential functions. So starting with domain. Domain are all the possible x values a function can have. It is how far left and right the graph goes. Range is all the y values the function can have. It is how far down and up the graph goes. For the x-intercept, we're familiar with x and y-intercept because we saw those when we were graphing lines, but an x-intercept is the point where the function crosses the x-axis, and remember we list that point as whatever the x value is, comma 0. The y-intercept is the point where the function touches the y-axis, and we list that point out as 0, comma y. And then lastly, this is a new word that we haven't heard before, an asymptote. An asymptote is a line that the graph approaches and gets really close to, but never actually touches. With exponential functions, these asymptotes are horizontal lines, so we write them as y equals whatever the number is. So we're going to take a look at some graphs and identify these 5 characteristics. All right, so here we have an exponential function. I know it's exponential because, as we say, it's kind of curved and it kind of flattens out on one side. This is an increasing exponential function. So for the domain, actually for all of our functions, it's actually going to be the same. So remember how we learned in the previous lesson that we can plug in x values to get y values. The domain are all the possible x values a function can have. Well, whatever the equation is of this particular graph, we can plug in whatever x value we want, and we're going to get a y value, which means that this exponential function has every single y value. The way that we say that in math would be from negative infinity to positive infinity. So remember, positive infinity is on the right, negative infinity is on the left. So for the domain, we're going to say negative infinity to positive infinity because we can plug in any x value and we will get a y value. Graphically, we can see that this graph goes forever left and it's going forever up, but as we can see, it's kind of going to the right as well. So this graph is going up and to the right, which is why we say it goes to positive infinity. For range, it's not necessarily going to be all possible y values. So for this, we can probably look at the graph, but for the range, let me use a different color. For the range, we can see that the lowest my graph goes is right here. And we'll talk more about that when we get to asymptote. But the lowest my graph goes here, but then we can see that my graph goes forever up. So for my range, we're going to say the lowest the graph goes is this y value. So it's going to go from -4. And it never actually touches -4. I know it looks like it on the graph, but it's actually just going to get really, really close to -4. And it goes on forever up, which we know is positive infinity. So range, we look down first. So my lowest value is going to be -4. And it doesn't actually touch -4, but it's going to get really, really close to -4. And it goes forever up. So it's going to be from -4 to infinity. All right, so for my x-intercept, we're going to look on my graph where it crosses the x-axis. So it looks like it's crossing my x-axis right here. Let me use green for that. So my x-intercept, so if it doesn't cross at a grid point, we're going to have to estimate. So maybe that looks like 1.25. So my x-intercept is going to be 1.25, comma, 0. Next thing for my y-intercept, we're going to see where it crosses the y-axis. That looks to be right here. That's going to be 0, -3. Okay, and then last thing we're going to look for our asymptote. So for our asymptote here, it's the line where our graph gets really close to but never touches. So that's actually going to be at the bottom of my range. So my horizontal asymptote is at this y value. So we're going to write it as y equals -4. So one thing to make note of is the asymptote and the range are related. Wherever your asymptote is, that's going to be a part of your range. So as we see, the lowest our graph was -4 and the highest was infinity. And we know that our asymptote is at -4. All All right, so let's take another look at another example. So again, starting with domain. So remember, if this were an equation, which there is an equation for this graph, although we don't see it, we can plug in any x value and we're going to get a y value. We could also see that our graph goes forever kind of up and to the left and forever to the right. So the way that we write that in math terms is negative infinity to positive infinity. Okay, now for our range, we're going to look and see how low does our graph go. Well, the lowest point of our graph looks to be right here, and our graph goes forever up. So in terms of our range, it looks like it goes from 2 to infinity. And actually, if we wanted, we can actually go ahead and say that that's our asymptote, right? Because we know that our line, I know it looks like in this picture, it's never actually going to hit 2. It's going to get really, really close to 2. So wherever it's flattening out, that's what the asymptote is. So for the asymptote, we're going to write that as y equals 2. All right, so for my x-intercept, we're looking at the point where it crosses the x-axis. Well, here's my x-axis. We know that my graph's going to get really, really close to 2, but it's not going to go any lower. So my graph is actually never going to cross my x-axis. So in this case, there is no x-intercept. So your graph does not have to cross your x-axis. If it doesn't, you would say that there's no x-intercept. Y-intercept, it will cross your y-axis at some point, since we know that our domain is from negative infinity to positive infinity. And on here, it looks like our graph crosses the y-axis at 3. So we would write that as 0, 3. All right, here's another example. So let's start with domain. So domain are all possible x values. As we said, for exponential functions, it's going to be the same for all of these. It's going to go from negative infinity to positive infinity. For range, we are going to look and see how low does our graph go. Well, in this case, since this is a decreasing function, we know that the lowest my graph goes, it's going to go forever down, which means that the lowest it goes is going to be negative infinity. The highest point my graph goes looks to be 2. So when we write range, you need to make sure you go from bottom to top. So if we go from bottom to top, the bottom is negative infinity all the way up to 2. And remember, it gets really close to 2 but doesn't quite touch 2. So we can actually go ahead and do our asymptote as well. Okay, where it's flattening out is going to be our asymptote. So that's the asymptote. And it's going to be y is equal to 2. So remember, your asymptote and your range should share a number. Now let's look for our x-intercept. Our x-intercept is where it crosses the x-axis. So it looks like our graph is crossing the x-axis here at the origin. So that's going to be 0, 0. And then in terms of a y-intercept, it's actually going to be the same point. So it crosses at the origin as well. So that's 0, 0. All right, lastly, here's a problem from the homework. So let's start with the domain. As I've been saying, domain are all possible x values, and it goes, you can plug in any x value to any function. So that means our domain is going to go from negative infinity to positive infinity. For our range, we're going to see how low our graph goes. So this is a decreasing function. So we know it goes forever down, right? So that means it goes from negative infinity. And then the highest my graph goes is right here, so that's negative 3. So from negative infinity to negative 3. And then from there, let's go ahead and do our asymptote. Since we know the asymptote and the range are related, our asymptote is going to be y equals negative 3. For our x-intercept, we're looking to see where our graph crosses the x-axis. Well, as we can see, the highest our graph's going to go is negative 3, which means it's never going to cross our x-axis. So that means there are no x-intercepts. So we're going to say none. And then y-intercept is where it crosses the y-axis, which is this point right here. That's at negative 4. So we're going to write that as 0, negative 4.